All right, so we are talking about rafter uh, theory and being able to cut and or measure, mark, and cut out rafters. Today we're going to focus on the three different ways to cut out rafters. There's going to be a few definitions I want you guys to copy, um, and and I'll have you guys copy down a few steps. In the videos that I'm going to have you watch tomorrow, it's all going to be me laying out rafters and showing you how it's all done. So have a piece of paper ready and pencil, that way you can get everything marked down right. So you look at this, here's just some of the roof framing, all the framing members we talked about the other day. Any important ones for a raft. You have your standard rafter here. You've got ceiling joists, you got your walls, your double top plates, you have your ridge board, collar tie. Now that's all the wood framing members. Now when you get into the rafter, there's a few other things like plumb cut, bird's mouth, and tail cut. We'll talk about that. So this next slide here shows the actual rafter as it's cut, to fit. You have your ridge board up here. You've got a wall with your double top plates down here, and your plumb cut is going to be, the reason why they call it plumb is this cut here is supposed to be vertical compared to whatever. If you have a low slope or if you have a steep slope roof, that cut is going to be vertical, hence the name plumb cut. So you have a plumb cut here, and then the distance from your plumb cut down to where it's on the outside of the wall studs, that's what's known as your common length. So from here to here, that's your common length. Then you have a cut, because if you were just trying to put a straight board on top of flat plates, like if you did not make this notch cut out of here, then you wouldn't have a lot to fasten with and nail to, especially if the pitch is, or the slope is really steep. If it's like a 10-12 or a 12-12 roof, you would just have like a little bit of space. And so what they decided to do long time ago is to create what's known as a seat cut, or commonly referred to as a bird's mouth cut. So it cuts in and over. Now this cut here should be level, because the top of your plates are going to be level. It should be level. It can be up or down a little bit on the front or the back, but you want it to be as close as possible to level. So that's what's known as a seat cut of the bird's mouth. And then beyond the bird's mouth, this section right here is the tail of your rafter. And so this cut at the bottom is known as your tail cut, but the distance here is actually the distance from the wall to the tail cut is your overhang. The distance from your seat cut to your tail cut, that's known as a projection. Very, very similar, but it's just going to be a little bit different there. So those are the parts here. So what we're going to discuss today is, if you have your rafter piece, how are you going to mark this, and how do you find this length? Where do you put your marks here for your bird's mouth and then your tail cut? That's what we'll be talking about. To do that, you've got to understand a few terms first. So I want you all to copy down these three statements here. Okay. Number one, you're going to need to know the span. What the span is, the horizontal distance from the outside of opposing exterior walls. So if this is your roof here, red lines would be in your rafters. If there's one wall, here's another wall. What you're going to measure the distance from the outside of one wall to the outside of the opposing wall. That's what's known as the span. Okay, so your roof spans that whole distance. And it's very important part of this. Now, The second term here is run. That's the horizontal distance from the outside of an exterior wall to the center of the ridge board. It's usually half the span. Now, sometimes, like most of the time you're working, you're going to have a symmetrical roof. Sometimes you're not going to have a symmetrical roof. And in those cases, your span is going, or your run is going to be different. But if it's a symmetrical roof, let's say it's 20, your span is 20 feet wide, you're going to have a 10-foot run. If it's a symmetrical roof, if it's not a symmetrical roof, you got to do a few other things, but it's usually going to talk to you about that in the plans. So run is half of the span. So you can see run from the outside of this wall to the center of the ridge board. There's your run on this side, there's your run on that side. And then you have your rise. That's the vertical distance from the top plate to the top of the ridge board. So from the top of the top plate to the top of the ridge board, that's your rise. So your run, that's your left-right measurement. Rise is your vertical measurements. Now, if this sounds familiar, maybe you had something like this in your geometry classes when you're trying to calculate slope. And the formula for slope is rise over run. That's right. So very similar. And this is where you're going to be using that geometry and that actually trigonometry, if any of you are taking trigonometry classes. Now it's more basic trigonometry, but it's applicable. This is the application of what you've been learning in your other classes. So if you were to look at this large triangle here and take this down to just the right side of it, it's a triangle. You have your rise, your run, it's going to give you your slope. So rise over run. Okay, you all should have these by now. If you don't, pause it, finish typing or finish writing out your definitions and move on. Got two more on the next page. Okay, so the next one is the unit triangle. This represents a smaller scale shape of the roof. And what you're commonly going to see is you're going to see it's not going to be a triangle like this. They're going to give you something like an inverted triangle to where the slope is on the bottom. You have your rise and you have your run. Now sometimes it's going to go rise and run to the left. Sometimes it'll go rise and run to the right. Just depends on which side of the roof they're putting this on. But you'll see it on your plans. And it doesn't actually have to be a full triangle. You might just see oh, that's terrible. Okay, let me go back and do this one more time. You might just see your like an L shape, like this. So this would be your rise. This would be your run. That might be what you see. And they'll print out like 4 and 12, or 6 and 12, or 12 and 12, whatever it is. So you might see a full triangle. You might just see two lines with number on the top, number on the side. That represents your unit triangle. And these are key numbers. So when you're trying to determine, okay, how steep is that slope, that's your rise and your run. If you remember back into carpentry 1 or construction 2 classes, or even intro classes when I would teach them, I would talk about using a not frame square, a speed square. I was going to call it framing square, but a speed square. Use your speed square, and then you can determine what angle a roof is by degrees. But then there's that slot in the middle that has different numbers, smaller numbers on there. 1, 2, 3, 4, 5, out to like 30. Doesn't go all the way up to 90, just does 30. Those are your rise over runs. That's your slope measurements. And one of them, so you can set that up if you know you have a 412, you can just put it on that 4 and it gives you that angle. And you mark it and you're good to go. If it's on 10, you can do that. So you don't necessarily have to know the degree of it. Okay, so the unit triangle is here. Also, this is important because the distance from here to here, we're going to need to know later. Okay, okay, so slope is the next one here. It's the inclination of the roof surface. Inclination is it inclined? You know, what's the angle of it essentially? The same. It's expressed as a relationship of rise to run. Now, some people will call this pitch, and some people will call it slope. Like you'll hear people say, "Oh, that's a 10-12 pitch roof." It's not exactly right. It's a 10-12 slope roof. Uh, pitch is it's a different way of looking at it, but you can still figure out the same thing. It's how high you go up versus how far it's like a ratio. Pitch is a ratio. 10-12, 8-12, 3-12, all that is slope. Okay, so remember that aspect. That way, when you hear somebody talking about it, oh, that's a 10-12 pitch, you'll be like, you can correct them, say, no, it's not exactly right. Huh. It's always kind of fun to do that. All right, so you guys should have these done by now. All right, so here I have pictured a framing square. And on that framing square, it starts down 0. On the outside of it, you've got inch measurements going out to 16 inches this way, inch measurements going out to 24 inches this way. So the whole rise over run thing essentially is from 0. This will represent your run here. So you go count out to 12. And you could do it the other way, but this is just showing here. So you can do this at 12. And then however many inches you go up per 12 inches you go out, that's your slope. So if you had a 412 slope, so here's 4 inches, there's 12 inches, this would be how steep your roof is. Not very steep. Side point here, you may remember me talking about in OSHA classes, is that a 412 slope is the highest or the steepest roof you can go without having to use guardrails with toe boards or safety nets, or even guardrails. If you have a safety monitor and you're doing roofing work, then you don't actually have to have any of that stuff. However, if you're doing framing work, you need to have harnesses on. Okay, so 412. All right. If it's 8 inches up and 12 inches over, there's your 812 slope. And as you can see, they go up from here. And you've got 2, 3, 4, 5, 6, 7, so on and so forth. Now, on the other side here, you can see some lines coming in this way. That's going to talk to you about the pitch. So a 412 slope is a 1/6 pitch. Okay, it's a 1 6 pitch. If you go to a 612, that's a quarter pitch. If you go to an 812, that's a third pitch. And then you have all these other fractions. And honestly, oh, eyelash in my eye. It's always fun. The math working on that, we're not going to focus on that. But pitch is different than slope. Just remember that. We're going to be working with slope. All right, so how to measure and cut the rafter. There's several different ways. You don't have to copy this stuff down. I'm going to have you copy just 2 of the other methods down. For simple roofs with just one ridge beam, this is your process. You can divide the distance from outside bearing walls in half. So divide your span in half. That gets you your run. Find out how high the top of the ridge is going to be. That's your rise. Then you're going to use Pythagorean theorem to find the lengths of the rafter, which is C here. And this is where you guys remember Pythagorean theorem, a squared plus b squared equals c squared. So a times a plus b times b equals c times c. So let's say if we had a run of 12 feet and then a rise of 6 feet, 12 times 12 plus 6 times 6 equals c times c here. 144 plus 36 equals 180. Now we got to find the square root of 180. So I punch in the calculator. It's 13.416, which that means the common length here is 13 feet 5 inches. Okay, so that way I can figure out, okay, 13 feet 5 inches there. Now this is excellent for figuring out, okay, how long of a rafter do I need? Because then, you know, okay, I'm also going to need some overhang here. So you can add that in and you can say, if you weren't going to have any overhang or have 6 inches of overhang, you would use 14 footer. But if you're going to have a foot and a half, you're going to need a 16-foot rafter. Okay, so that gets you there. Now, let's take a look at these here. These are just a few problems. Here's one roof. We have a span of 30 feet and a rise of 10 feet. Okay, so we take our span divided by 2, and that's going to give us 15. So 15 times 15 plus 10 times 10, and that's going to give us 225 plus 100. That equals 325. And then the square root of 325 is 18.02. Okay, and that's 18.02 feet. So 0.02 feet is like not very much. It's not even an inch. So the common rafter length would be 18 feet. You need an 18-foot rafter plus any overhang. All right, let's take a look at this other one. It's a 20-foot span with an 8-foot rise. Okay, so 20 divided by 2, that's 10. So 10 times 10 plus 8 times 8, which is 100 plus 64 equals 164. And then we're going to square root that 164. That's 12.8 feet. Okay, so your common rafter length in 0.8 feet is equivalent to 9.5 inches. So it's going to be 12 feet, 9.5 inches. All right, now that's not too confusing. That's not too a work there. And it can be a lot easier if you download an app. This is called the Pythagorean calculator. It's very simple. So you can see it on here. And that's what you would look, I think that's what the symbol looks like there. And you can just type in find A, or typically you're trying to find C. So you type in what your A is, there's 8. You type in what your B is, which is 10. And then you hit equals. 12.81, at 12, I wrote down 12.8, close enough. And from there I can figure out, okay, how many inches is that? How many feet and inches is that? So that's an easy way to do it. You don't have to do all this math in your head or just on your calculator. Get an app. There's an app for everything these days. But wait, there's more. It's still not just that simple, because what this is measuring is the top of your ridge plate in the center of your ridge beam down to the outside corner of the top plate. But your position of the rafter is going to be a little bit different. Remember, it's the top of your rafter is not on that top plate. It's sitting up. There's your seat cut. So it just gives you your common length. It doesn't give you the actual measurement that you'll use to cut it. It's a rough measurement. So you can do this, but you're going to have to do things just a little bit differently. So if you have a speed square and a calculator, you can do this, a very similar thing here. Okay, I'm just going to go over this again. You don't have to write this one down. There would be 2 set of steps that I want you guys to write down, to copy down. So if you have a speed square and a calculator, much like I just did right there, lay out the top of the rafter. You got to figure out your unit run and the unit triangle. You got to find, you have to know the run and the unit triangle. So you need to know those 2 things. So just look at the plans. You can find those. Use Pythagorean theorem to find out the unit length, which is the distance here. So if we have a 612 slope, we got to find our unit length. Remember, this is just our small model thing here. So let's say the run is going to be, oh yeah, I don't have this. Say the run is going to be so I'm trying to do this without a mouse and it's difficult. Let's say our run is 12 feet. Oh, come on. Okay, our run is 12 feet, right? So we have a 6 and 12 slope. I'm going to punch that into my calculator here. 6 and 12, I'm going to hit equals. That's going to give me 13.2 or 13.42 inches. 13.42 inches. Let me make this a little bit. Okay. All right. Now that we have this 13.42 inches, we're going to multiply the unit length in the run to determine the line length, because that's going to say, okay, it's 13.42 inches from the top to the side of this triangle here, and then we're going to have 12 of these going down the length. So we take this number divided by or multiplied by 12, which 13.42 times 12, that's going to be 161.04 inches. So what that's going to be able to do is, now we know this, our line length is 161.04. So we're going to mark our plumb cut and measure out that line length, 161.04 inches, which would be like 161 and a 16th. And then you're going to mark out your bird's mouth cut, measure out your overhang for your rafter tail, mark another plumb cut, and or do your tail cut, and then theoretically you should be ready to go. So that's one measurement here, one way to determine this. Okay, so if we went all through this, and this is stuff that if you guys are in my class, you guys have an 8-foot whiteboard and we practice on the whiteboards. We don't have that. I'm going to show you one of these methods in my next video here. Okay, so your next one is you laying out a rafter with a speed or a framing square. Some people find this really easy. Some people prefer some of the math-based methods. But I do want you guys to copy down the information that you see here. I know it's a lot, but they're short sentences. So if you're working with a framing square, write down laying out a rafter with a framing square. First point that you want to make sure of is, with your framing square, you're using the same side of the raft or the square. You're not using the inside of one edge and then the outside of the other, because that's going to throw everything off. You can use the outside or you can use the inside, because they're going to have markings on both sides. Doesn't matter which one you choose, you just have to have the same ones. Otherwise, it's going to mess you up. Then you're going to use the square to step down the rafter. You can see from my picture here, it looks like there was a square here, square here, square here, square here, all the way down the rafter. So every time you move that rafter down, or that square down the rafter, it's like marking that unit triangle once, twice, 3 times, 4 times, 5 times, however many times you need to do. So however many steps you have to make, that's your run. So if you have your run of 10 feet, you make 10 steps down that rafter. If you have a run of 7 feet, you make 7 steps down that rafter. So And like I said, each step is 1 foot of your run. All right, so your first step here, 1 through 5, is you come on this end and you're going to mark your plumb cut. So if you have a 412, a 612, a 1212, whatever it may be, you're going to mark that on your end. Don't cut it yet, just mark it. And then you're going to align your square in that same thing. So like I said, if we have a 612, I'll have the 6-inch mark on the outside of this square and a 12-inch mark on the outside of this square. I'll line that up with my plumb cut, and then where the outside of this crosses the edge, I'm going to put a little mark right there on my rafter. And I'm going to move my rafter down until this edge of the rafter meets up with it, and then my 6 is on that mark, and then my 12 inches is on the edge of this rafter. I'll make another mark here, and then I'll move my rafter down again. Now, this is made a whole lot simpler if you have framing square clips. They're the little brass knobs that you can clamp on there. You see these little circles here. Basically what it does is it clamps and it holds that in position, so you don't have to physically measure your 6 and your 12 every time. Once you have it set up one time, you just move it down. Move, mark, move, mark, move, mark as many times as you need to. So you'll continue this all the way down. However many steps you have is, eat every foot of your run. So step down the rafter at 1 step per run, and then you're going to measure out and mark the bird's mouth cut. So your very last one, that's going to tell you you're going to do another plumb cut, another 612 angle straight down, and that's going to give you your position for your seat cut or your bird's mouth cut. You'll mark that out, and then you're going to measure and mark out your overhang, how far you go down again. Usually it's 12 inches. So you'll come over another 12 inches, finally mark your tail cut at the end of this. So you're going to actually have, if you're stepping down a rafter, you're going to have a mark at the top, that's your plumb cut, and you're going to have a small mark every foot. Now, some people, as they're learning how to do this, will square across, square down, square across, square down, square across, square down, square across every step. And it'll look like stair steps, but you don't cut those. That's just for visualization about the way it works. You can do that. You don't have to do that. So come all the way down. Then, so you'll just have some reference marks along the top of that rafter, and then you will have another line coming down, and then you'll mark out your seat cut. I'll give you guys more detail about how to mark out a seat cut later on. Then you'll make your overhang, and then your tail cut. Okay, so there's 5 steps in here for laying this out, and there's some information. You guys should have that down by now. Okay, now, again, we're going to skip this one. Okay, this is like my favorite way to do it because there's not a whole lot of thinking involved. And you know what? I had a book here. My daughter came in a few minutes before I started and wanted to look at it, and she ran off with my rafter book. But if you buy a Swanson Speed Square, or if you buy a Johnson Speed Square, however it is, they're going to give you a book. And it's about a 60-page little book. It's only about this big, right? In fact, this is roughly the size of the book. This is almost actual size right here. And in this book, the first half of the book is all this knowledge. Those things I'm telling you, it's in this book. So there's tons of reference. It tells you what span is, what rise is, what run is, what your unit triangle is. It talks about the different framing members and the different slopes. But the real wealth of information are these rafter tables. Using rafter tables, it tells you the width of the building. So here's your spans, okay? And each page, I know it's hard to see up here, but the pages look like this when they're set up. but they give you your inch rise. So if you're doing slope, if you're doing a 512, here's your inch rise, that's 5 inches. And if you have a 30-foot span, 5-inch rise is 16 feet and 3 inches. That's your unit length. So they've done all of this math. Everything that you don't have to think about now is here. So this one is really, really easy. Number one, determine your span and the unit rise of your roof. Again, consult the plans, look for 2 things. Then you look at the rafter tables to determine your line length. And literally, that's finding your inch rise and your span. You just make sure you get the right columns. If you don't get the right columns and rows, it's going to be messed up. Then once you have this, you're going to mark your plumb cut. Actually, I'm looking at this, it's a little bit off here. So step 3, don't write down step 3 as this. This is going to be a little bit farther in. So you're going to mark your plumb cut at the top of your rafter. You're going to look at the tables and figure out that 16-foot 3. You're going to measure out your common length. You're going to mark the bird's mouth next. So plumb down, mark the bird's mouth. And then you add in the necessary length for your overhang, your eave overhang. So this should be step number 6. And then each of these should be moved up 1. Okay, my apologies for not having these in the right order. And then at the very end, you're going to measure out your eave overhang. I guess it's really a 6-step method. I can just delete that 1, huh? I've got it in there twice. All right, let me fix this real fast. Can you guys hear all the commotion? Oh, good gracious. Delete 4. Delete 5. 6. Okay, so there's 6 of them here. Determine the length, or determine the span and the rise of the roof. Consult the rafter tables to determine the line length. Mark your plumb cuts. Measure out your common length. Which common length and line length are basically the same thing. Mark the bird's mouth. Measure out your eave overhang and tail cuts. So this method is quick. So I'm going to show you guys in my video exactly how to do this. It's super fast because, like I said, they did all the math for you. All right. All right, that's all for today. I'm going to talk about, other parts, installing some of this stuff on the next video that I do, or next presentation video that I do. So write down all of your stuff, take a photo of it, submit it, and I'll see you in the next video.